Yes, good afternoon all. We'll be starting the session around 2 5 p.m. Uh, we'll let the participants to join in, and I would like to request the participants to please keep their mics on mute and just see any accidental presentations. Right now, Praveen Kaur 1008. बेटा आप अपनी स्क्रीन प्रेजेंट कर रहे हो. Please stop sharing your screen. Yes, Praveen Kaur 1008. Yes, good afternoon all. Yes, beta, you're presenting your screen. Just stop presenting your screen. Yes, Kajal Maurya, you are presenting your screen. Please stop presenting it. Kajal Maurya, please stop presenting your screen. welcome Mr. Manny Grewal. I'm here. Good.
Hello, Aman. Hello, everybody. How are you guys doing?
We'll be waiting.
Thanks, Aman.
Yeah, we will be just waiting for 3 to 4 minutes, and then you can take over the session.
Sure, Aman. Thanks. So I'll go on mute. Let me know when my turn comes. Thanks, Aman.
Thank you. Guys, good afternoon all. Uh, just to introduce the amazing guest speaker that we have with us today, Mr. Manny Grewal. Uh, Speaking about his accomplishments, he has got many accomplishments. I will not be able to describe all of those. Just a brief about his professional accomplishments over the period of time. He started his professional career in 2003 onwards, and then he has worked with numerous MNC companies, including Microsoft Corporation, serving various important roles in the form of system architect, technical architect, and providing end solution architectures to the clients. Presently, he is working in enabling the digital transformations for the federal government using this Microsoft platform. He is currently working in Canberra, Australia. So I'm pretty sure that today's experience is going to count a lot, and it will be an amazing experience for all of us. And I would also request the candidates to please keep their mics on mute and presentation screens on void. And during the end, or during the ongoing session, the participants they can post their queries in chat message windows, and Mr. Manny Garayal he will be attending all those queries during the session end. Thank you, Mr. Manny, and you can have the session. I'm stopping my presentation.
Thanks, Aman.
Yeah, right.
Hello, everybody. I'll just share my screen. Just give me a moment.
Sure.
Can you guys see my screen now?
Yes, sir.
Yes, sir.
Cool. Thanks. Good afternoon, everyone, and thank you, Aman, for the wonderful introduction. And today I'm going to be talking about machine learning, which is one of the hot topics these days. As you guys know, data science has been really in market in demand these days, and machine learning is one of the streams of data science. So what we're going to do is we're going to touch upon the process of machine learning, like what this thing is all about, and we will also see a demo later on of how machine learning is actually carried out using the Azure tool. Let's delve into it. So before we start, I hope you guys can still hear me. It shows I'm on mute. So let me know if you guys have any hearing problem. I think so far it looks good. So before we start, a little bit about me. I've got around 17 years of experience in IT software development, and I've worked in a lot of multinational companies. I started my career with Infosys. Then later on, I moved to Microsoft. Primarily, I was working in the .NET development platform domain. And from last 10 years, I'm working in Australia as a technical architect. And I'm working in a consulting role, which means we work for clients, we take their requirements, and we tailor fit software as per the requirements. So we build software for them. This role involves various kind of positions. It could be an architect position. When the project starts, you need to, design the system as an architect. But later on, you have to also move on to implement the system. This role involves, multiple positions, be it an architect or a senior software developer. And later on, we have to also work on, making sure the system is accepted by the users, and so that the project phase works end to end. My focus has been primarily on the Microsoft stack, and recently I have been working on Dynamics 365, which is one of the CRM technologies from Microsoft. This is a platform where you can build ERPs, which is your enterprise resource planning system, as well as your customer relationship management systems. And most of the work I've done is around .NET, which is like writing code in C#, building applications in .NET Core and other .NET platform stack like MVC, which is basically the web application development and those kind of things. And I've been also involved with Azure. Azure is one of the cloud platforms from Microsoft. As you know, these days, cloud is one of the primary infrastructure platforms, because now we live in an online world. Everything is served through clouds. So cloud is one of the hottest technologies these days. And what we are seeing here in Australia is, especially in the federal government and other local governments, is slowly there's a transition from the traditional on-premise system, which is where companies had to buy a lot of hardware, a lot of equipment, and they have to host all that on their premises. But these days companies don't want to spend too much on all that. So what they do is they actually rent some space in cloud. So basically they just sign up for the cloud services, so that they can pay as they go. Like, because these days in the IT industry, the trends are changing quite often. Like every 3 years, technologies change a lot. So clients don't want to invest too much into infrastructure. They don't want to invest too much into licenses. They rather want to have a flexibility of starting with a very small footprint, where they don't do too much investment. They just want to try the technology for a year or so. If they like it, if the businesses adopt it, they will probably renew the license for another year. Or they might think, okay, oh, this is not the way to go. We have to probably try something else. So cloud gives them that flexibility, where they can, without doing too much investment, they can actually try the technology, see if the users like it, and then if not, then they can probably move to another vendor or another technology. So Azure is that platform where all these technologies from Microsoft, they're getting clubbed together into an online environment. So that's called Azure. And machine learning, obviously, we'll delve more deep into today. So I have a bit of experience around machine learning as well. So yeah, so a bit of a agenda. So what we're going to do is going to do a quick introduction, because it might be new for some of you guys and girls. You won't know what machine learning is. So we'll touch upon a little bit some of the machine learning processes. We'll see a bit of a use cases around machine learning, and we'll also see some of the learning techniques. So we also see some of the learning techniques, the primary learning techniques with machine learning, and then we'll see a demo at the end. and we'll wrap it up doing a Q&A session where I'll go through some of the questions from you. So let us first understand, what this machine learning is all about. So basically, the main gist of machine learning is we actually show a lot of data to the machine. Here, the word machine means computer, obviously. So what we do is we make the computers understand the data, and we also want the computers to predict if they see a new data, what will be the result. Basically, what happens is when the machine or the computer, when they see a lot of example data, then they learn from it. They learn the patterns within the data, they learn the trends, and then they can make decisions. Then they can take decisions based on some of those patterns. So that's where the word machine learning is. When machine, if you look at this diagram, I'm not sure if you guys can see my mouse pointer, but basically if we start from the top left, what we have is we have a data set. So data set is like a database where you have a lot of records. It could be millions of records. It could be, let's say the example of, let's take the example of cricket, which is favorite with everybody. Let's say the cricket match where we see uh, we see two teams. We also see uh, the situations in which those matches were played. For example, if it is a home ground, and if we know if it is a first match of the World Cup or the last match of the World Cup, then we can see a lot of these examples in the past, and then we can predict if a similar match is coming up, then we can predict which team is going to win. Not exactly, but we can have some level of confidence. For example, in India, if we take India, Pakistan, we know when they go to the World Cup, which country has a more chance of winning in a World Cup. So that could be one simple example. What we do is we actually see a lot of examples, and then we do a process of data cleansing, because what happens is all of our data may not be accurate. Some of the data might have missing rows, it might have missing records. We don't want to include those records into our process. We want to clean them out. We do this process of data cleaning where we look at some of the rows. If they're not right, we just want to remove those rows. Then the third step is the feature engineering, which is what we do is in this process is if a data set has got say 1,000 rows, we want to categorize those rows. Like one of the example could be, we are looking at a demographic data, which is we have person's age, we have person's income, we have person's marital status, we know person's district or their address. But what we rather want to do is we don't want to take all the ages. We want to categorize those ages into age categories. It could be 0 to 30, 30 to 60, 60 to 90. Or for some things, we also want to take an average. So those kind of operations are done during this feature engineering process where your data scientists, they come in, they actually have a look at the data. Sometimes they want to categorize those data into a simpler category so that it is easier for the machines to understand and ingest that data. What happens after that is the feature engineering phase. The next phase is the training phase. So what we do in the training phase is we actually we take 80% of the data and we build an algorithm for that. In what we do in this case is the algorithm actually instructs the machine to learn from that 80% of data. So what the algorithm does is it actually looks at the trends in that 80% of data, and then it tries to build a model. So model is like a compiled, it's like a compiled state where it's like a very fast, lightweight, compiled binary object, or which is what the model is, which can actually make very efficient decisions. So in training phase, all we're doing is we're showing your algorithm that 80% of data so that it can construct that model to actually act on that data. So that's your top part, which is the training phase. And your bottom part is where you start making the predictions. Because the whole purpose of machine learning is we are building a system which can make predictions, and we're building the system based on past data. So that, to give you the same example of a World Cup, we are building a system which can look at all the past data of two teams, two players, two situations, two grounds, whatever the case is. It could be the Duckworth-Lewis, when the Duckworth-Lewis occurs, we know a particular team has a more edge of winning. So the machine will, go through click info or wherever all those records are stored. It is going to learn, based on all those parameters, and it's going to build a model so that when a similar match happens in future in similar circumstances, it can tell you which team has more chance of winning the match. And then it can tell you with certain confidence level. Because obviously, it is just a prediction. It's not a prophecy or anything. So the machine is making its best judgment. It may be right, it may be wrong, but when it makes that prediction, it tells you the confidence level, like what percentage the machine is sure of that prediction. It could be 80%, it could be 70% or whatever. So the whole thing is basically what we're doing. Can you guys still see my screen?
No, sir, it's not visible.
Sir, it's
It's
yes, sir.
visible. As you need to pin the screen of Mr. Manny Grewal, you need to pin the screen.
Sure. Let me try to present it again. That's fine, guys. I think. Give me a moment. Let me try to actually go to that screen. Cool. I hope you can see it now. Cool.
Yes, sir.
Cool.
Yes, sir.
Cool. So let's carry on with the same example where we were. So we were talking about this process. So what I'm saying is, so why do we do machine learning? The main point of doing machine learning is we want to build a system or a machine which can actually start making predictions when it actually sees the data. So if you guys put yourself in mute, that will be great, please. So as we have seen in this model, so at the top right, we have trained our machines to look at examples. We built a model. And now when we go to the bottom left, where we say new data, that means when a new occurring happens or a new circumstance comes, then our model can actually make a prediction. So that's called scoring and evaluating, so which is at the end. So let's actually see in the next example where it will become more clear. So this is, let's take a very simple practical example. Say, for example, there's a golfer, and the golfer plays every day. And what the golfer does is he actually also keeps a diary or a history or a database where he says, based on the climate or the weather or the outlook, whether it is sunny or there's an overcast, which means cloudy, or whether it's a rainy, also based on the temperature, also based on the humidity. So based on all these factors, the last column is whether the play happened on that day or not. So the most important column is the last column because that's the actual result based on the first four parameters. What we're doing is every day we are recording whether the golf happened or not, whether, on that particular day. So the whole point of this is so that you can predict based on tomorrow's parameters whether the play will happen or not. This is another one example of machine learning where we train a machine to look at all these weather patterns, and we want to predict, whether there will be a chance of a golf game tomorrow or not. So just to recap, this is a very condensed model of what we saw in the previous screen. We have a concept of samples or examples. Like in this case, as I was talking about, we train the machine through previous historic data. So that in technical language, we call those things samples. The sample is all the history, then we train our history. We build an algorithm based on all those histories, which is the middle thing. And then when the new data comes in, which is tomorrow's weather, because obviously we know, tomorrow, based on all these websites, we can tell tomorrow it's raining, what's the temperature is going to be, and all those things. And then our model can make a prediction, which is the blue label, that is the golf going to happen or not, based on the previous data. So that's the gist of it. That's the gist of the machine learning process. So why do we want to do machine learning? Some of you guys will be asking, okay, we understand, what machine learning is, but why shall I be interested in it? So these are the industry use cases. This is how prevalent machine learning is in different industries. So I've taken this slide where you can say these are the various sectors: manufacturing sector, retail sector, health sciences, travel, hospitality, finance services, energy. So no matter which industry you go, there is a lot of use cases and a lot of applications where machine learning is playing a more and more important role these days. With the emphasis on profitability, with the emphasis on cutting down the cost, with the emphasis on making more and more smarter products quickly, with the growing market these days, there's a lot of need of automated decisions to be taken. That's what machine learning enables you to take all those automated decisions. As you can see, there are so many. I don't want to read out all these use cases. You guys can read it all yourself, but it is very apparent now. It is a very a job or a job trend which is very hot in demand across all these industries. Let's quickly touch upon main 3 learning techniques in machine learning. Obviously, we got a limited time. We're not going to go in detail, but basically I want to touch upon main 3 types of machine learning techniques very broadly. So the first technique is called clustering. So in clustering, what we do is, the whole purpose of clustering is to predict which cluster or group your data falls in. To give you an example, let's take an example of a transaction. In banks, we do a lot of transaction happens. You withdraw your money. Sometimes you're overseas, or sometimes you're in another state. You withdraw the money from there. You may be depositing the money. So what the banks do behind the scene is they keep an eye on your transactions, and the main purpose of the bank is to detect if the transaction is fraudulent. They want to detect the fraud. If some kind of scam is happening, the banks want to stay on top of that. So let's take an example, the ICICI Bank, or HDFC, whatever banks you guys have. So any transaction happens in your bank account, the bank want to quickly flag whether the transaction is a risky transaction or it's potentially risky. So, can you go on mute, please? So yeah, so that is one of the clustering example where any transaction, the machine learning system wants to actually categorize it. Is it a high risk transaction or is it a medium risk? It just wants to flag it. If it's a high risk transaction, it will send you a SMS alert to you or your bank manager. Some fraud is going to happen. So that is one technique where we want to predict what category or what cluster the data lies in. That's called clustering. The next level of technique is called regression. So regression means we want to predict the value of a data based on the past values. That could be your stock price example. If you're looking at your stock price, this is one use case where, based on the economic condition or based on what is happening in the market, you want to predict whether the stock market is going to go up, or one particular share is going to go up, or the share is going to fall. So that is your regression, where you look at all the historical data, you do all this analysis, you look at the current state, you look at any immediate trigger. For example, if the company is going to announce their annual result and we know the company has done well, we know the stock price is going to go up. Or if there's a problem with outsourcing, if it's an IT company and America has done something with the visas, then we know the company will get impacted and maybe their price will come down. So that's a regression, means we're trying to actually predict a value of something. It could be stock price, it could be anything. Right? Then there's another technique called classification, in which in classification and clustering, the main difference is in classification there are only two classes. It could be yes or no. Like in this scenario, it could be fraud or not fraud. Like a transaction could only follow in two categories. But in clustering, there could be many. That's the main difference. So let me quickly see how we're going with time. Okay, so we got some time left. So let's quickly see a demo. What I'll do is I'll unshare my screen and I'll share another screen in a minute where we'll see the demo of machine learning. Give me a moment. Just give me a moment. I'm going to share another screen. Here we go. Can you? Hopefully you can see another screen now, which is Azure Machine Learning. Let me know if you're not, but I'm assuming that everybody can see my new screen, which is the. So basically, what it is. So far we have tried to touch upon theoretically what machine learning is, but how does it happen practically? So as I told you earlier that I'm from Microsoft background, so I have mostly dealt with machine learning in the Microsoft context. So what we have is we have a Microsoft product called Microsoft Azure Machine Learning Studio. So what you can do in this product is you can do all those steps which we saw in the previous slides, starting from the data set to your training to your predictions. As you can see at the very top, this is my machine learning training experiment. What I have over here is I have a data set of, it's called adult census income binary data set. But basically what it is, it's a data set of people. It's a data set of various demographics. It tells person's age. Let's have a look at data ourselves rather than me speaking. What I'll do is I'll actually show you the data set. So what we do for that is we actually right click on this and we say data set and then we say visualize. So that will open a view. And as you can see, these are all of our columns in the data set. So we got 15 columns and we got 32,000 rows. And as you can see, these are different columns in the data set. I got age column, which tells me person's age. I got their work class, which tells me which class they belong to. Like, are they working privately or are they working for government? Those kind of things. Then we got their education level. Have they done bachelor's? So we got various demographics in various columns. But the whole purpose of that data set is we're trying to actually predict whether the person's income is more than 50,000 or the person's income is less than 50,000. And this is like dollars, not this is from the US start. US. Just give me a moment, I'll get some water and come back. While you guys can have a look at the database. Some water. Sorry guys, I'm just back. Just want to have some sip of water. Okay, so the purpose of this database is we're looking at various characteristics of a person, and we want to predict whether the income is more than $50,000 or the income is less than $50,000. And we got a lot of examples. If you recall from the previous slides, we have to train our machine with all these examples. That's why we got sufficient 32,000 rows. And we want to make a prediction on this last column that if I have a new row and I tell the machine, the person is a female and, the person is like a postgraduate and this is the person's age, can the machine tell me, does the person earn more than 50,000 or less than 50,000? So that's what the whole purpose of this experiment is. So we have a data set. Then the next step, if you recall, it was around cleaning, data cleansing and data feature engineering. So that's your step called clean missing data. What you can do over here is You can do all those techniques, like you can, if some data is missing, you can replace it with mean. These are all the mathematical and statistical techniques we use to impute the data. But basically here you can choose to, if you don't want, that to consider that particular row, you can remove. You have the option of remove the entire row or entire column, or you can replace it with the mean. So those kind of things you can do in this thing called clean missing step. Then we had a step around feature engineering. So all that feature engineering stuff, we also have a dedicated tab actually over here if I want to show you. So towards the left, we have this tab called feature selection, where you can do all those processes around feature engineering. So that is all done over here. Then we got a split data thing where, as I was talking earlier, like if we got a data set, then we train the data set with 80% of the data. So that's what you do is, this is your entire data set coming in here, and we are splitting here. It is 0.7. That means 70% of the data is used to train the model, and 30% of the data is used to score the model, which is another step. So yeah, so that kind of split is done over here. And then to the heart of every machine learning experiment is the algorithm. Obviously we're not going too much detail into all those algorithms and stuff, but every machine learning process needs to have the right algorithm applied. Like in this scenario, we're using a 2-class boosted decision tree, which is one of the algorithms. So what this algorithm will do, it will actually understand all the patterns within this data, and then it will build a model. So you have this train model thing. So you build the model in this step, and then the next step is we want to actually check whether the model is right or not. We've done the algorithm, we put some parameters in this, but how do we actually know, whether it is performing well or not? For that, we have this step of scoring the model. So what the scoring the model does is 70% of the data we use to build the model, the remaining 30% of the data we will actually use to check the accuracy of the model. So that's what this scoring process does, and the evaluation process does. So there actually we check, whether the model is good. If it is not performing well, then you have your benchmarks. If it is it has to have 90% or 95%. If it is not performing well, then what you do is you go back to your algorithm. Either you change these parameters, or you throw the algorithm and you pick up another algorithm. Like in this case, this algorithm may not be a fit. You might have to use neural networks, or you might have to use binary classifier, or there are so many algorithms, like maybe dozens of algorithms. So you need to choose the right one. So that's what the machine learning engineer, all these data scientists, that's what the main job is. So they are given a problem. They need to build really efficient models which are highly accurate. So when those models see new data, they need to make really high percentage correct predictions. If the predictions are coming wrong and again, then those data scientists or engineers are not doing a good job. They need to build really high benchmark algorithms or algorithm machine learning processes. Yeah, so that's what I'm trying to show you practically, what the machine learning people do day to day in their jobs. They do all these processes. This was a very quick 5-minute introduction, but in reality, it takes more and more iterations, much more time. So let's see what else I can show you. Yeah, I think this is the whole machine learning. If you guys have access to Azure, you can sign up for a demo account or something. You can play around. But this is one of the technologies, Azure Machine Learning Studio. There are many other technologies as well to play with machine learning. Python is one of them. Python is a very flexible, very broad, very powerful language, which is predominantly used for machine learning. There's another one called R Studio or R, that is also very popular with some of the folks. There are many others, you can play around, but these are the main one: R language, R, Python, and Machine Learning Studio. which you're looking at right now. So I'll stop sharing it and I'll go back to the another slide. Just give me a moment. Let me share my original presentation with you. Just give me a moment. Let me actually... Go back to where we were. I think we are right on time now. I mean, just for your benefit, what I'll do is I'll probably delve more into the things which you may be more interested in. I mean, we have tried to cover, as much as we can in the given the time we have. But I think what is more important for you is you might have a lot of questions. So some of the common questions I've received. So probably I'll touch upon those questions. And if you have any more questions, probably you can pop them in the chat window, or we'll try to cover them however many we can. Other questions I'll probably take over email. Ask Professor Aman to actually send me over email. So let's touch the very hot question which everybody has, that I want to become a machine learning engineer. I'm just a graduate, or I'm even doing my bachelor's. So what is my roadmap? How do I actually get about becoming a machine learning engineer? So basically, the main thing with machine learning is, as I talked about earlier, the main thing about machine learning is it is all about data. So you need to be really good at understanding the patterns in data. So there are two types of data. One is a database, relational database, which you all might have read. You write all these queries, left joins. That is all about transacting with the data, where you are actually storing data, retrieving it, or updating it. That is one part of it. But this part is more about analyzing the data. So this part is more about machine learning part is more about when you have a database, how do you actually build systems which can take decisions on the data? So you need to be really good at that part, which is analyzing data. You have to also understand a bit of a statistics. You have to understand average, median, or the normal, the stats, which we read, the people know from the economics, those kind of backgrounds, they might have understood. I'm not sure in engineering it's very popular or not. You may not have read it in your engineering curriculum, but to go into the machine learning stream, stats are very important. So you need to understand, how do I actually make data more meaningful? How do I actually remove the outliers? Because we don't want to build a system based on outliers, because there could be an anomaly in the data. We want to pick up those anomalies and remove them, so that machine is more learning from the genuine examples rather than learning from system errors or mistakes. So yeah, so you need to be really good at stats. You need to be really good at analyzing data. You need to be good at some of the mathematics as well. There's a bit of a mathematics involved in this as well. Some of Fourier transforms and all those things you might have learned in your engineering mathematics, binomial, those kind of things. So they are also applied in some of the really complex algorithms. They can go to that level where those things are also get applied. So other thing is, in terms of practically, if you want to play around, I mean, basically, when you want to go for these kind of jobs, the multinational companies, they want people to do a lot of self-learning. They want people who already know the things. They will give more preference to those people who know about machine learning rather than training people on it. So what you can do if you want to learn machine learning in your own time, you can explore the Python language, which I touched upon earlier. So Python has a lot of packages around. One of very common is called pandas. So Panda is used for data cleansing, feature engineering, and those kind of things. So you can explore the pandas package. There's another package called NumPy. So NumPy is more around geometry and those kind of things. But yeah, in general, Python, you should learn, how to create a simple Python module and those kind of things. So Python will help you a lot, because Python is not only good with machine learning. Python is much more good in automation. Because not only it can help you in machine learning, if you go towards any kind of automation, testing automation, that's where Python can also help you a lot. It's very rewarding to actually understand Python syntax, build some programs, do those kind of things.
It's a more demanding.
Yeah, the modules. So another thing you can try is there's a website called. Sorry, I'm getting a lot of feedback. Can you guys go on mute, please? So another thing, yeah, please go on mute. Okay. So other thing is there is a platform called Kaggle, Kaggle, Kaggle. It's a website where you can learn a lot about machine learning. Basically, what they do is they host all these competitions where you can participate in those competitions, and then actually when you compete, then you learn a lot. When you compete in this competition, then you'll actually learn from professional people, like how they build their models. Once you go to that stage, and once you start competing in,
Python
well,
is the most important.
yeah, so once you start going there, that will actually give you a good ranking. So then you can display that ranking in your resume. So yeah, so those are sort of things you can do, to become machine learning engineer. And let's take the second question, like how do I get a normal software developer job with the MNC, like Infosys or Microsoft or whatever MNCs in India have, HCL and all these. Basically, as per my experience, I mean, my experience may not be up to date. I did this thing like 15 years back, 15, 20 years, I don't know. But now, I mean, I think most of it is still applicable. But what the most important thing in getting an IT job is you have to be really good at problem solving skills as well as analytical skills. So, all these puzzles, mathematical, logical reasoning, numerical reasoning. So there's an exam for that. They test that kind of skill set. Then what they also check is your knowledge about data structures and algorithms. So you need to fundamentally understand the data structures, like starting from linked list, arrays, linked lists, decision trees, binary trees, B plus tree, all those more complex trees, Dijkstra, graphs. Graphs are very important. So graphs are getting a lot of attraction these days. With Facebook purely runs on graphs, and all these new websites, Uber. So graph is one thing which is highly explored these days. Maybe just explore, build some algorithms around those data structures. So that is one thing. These big companies like Google and all, they will test you for those kind of skills. Other thing which is really important is a positive attitude. We talked about all those. You could be really good technical guy, and but if your attitude is not positive, if you're not a team player, if you don't have any good interpersonal communication, if you don't respect other people, if you don't respect the diversity, those kind of things can play against you. So not only you have to be good technically and a hardworking person, but you also have to have a positive winning attitude, also problem solving skill, and also you have to be a good team player. So yeah, so those are three things you need to keep in mind. So in your interviews, they will check for all these things, how good your attitude is. They have special HR interviews where they can find out where the person is lacking. So yeah, so these are two common questions I've got. If we got any more questions, probably I'll open the floor now. And Professor Aman, if you have got any other question, you can probably let me know. I can happy to answer that.
Yeah, thank you. Thanks for the insights. We have some questions listed here. I will probably say it like one of the student has asked, what is going to be the role of statistics and probability in machine learning? How these play a role in defining your model?
Yeah, stats is very important. As I said, like both probability and stats are really important. In probability, we have this, there is a bell curve. In probability, there's a bell curve, which plays a very important role. Like we have this 80-20% rule. So yeah, so probability is important where you can, because in probability, we actually find the chance of something happening. So same thing is happening in this machine learning thing as well. You're making a prediction of an occurrence happening, or you're making a prediction of whether your transaction is fraudulent or not. So yeah, so it's the same kind of model in machine learning. And if you want to learn it, as I said, like probably start exploring Kaggle, or there are a lot of online. Like these days, learning is not a problem. You can go to YouTube. There are lots of courses around that. You can pick your favorite person from whom you can understand. And there's another thing called Udemy. There's an online learning platform called Udemy. So yes, and then what you can also do is like, once you
It's a better from
sorry. Yeah,
Udemy is the best platform.
yeah. Udemy is an online learning platform. They have a lot of courses. So what
And
Udemy, all these
assignment,
days,
of course, uh, are post access Udemy.
yes. Yeah, so Udemy is one example. There may be more like that, but what these things do is they take a very they take a very structured approach. Like they teach you from the bare basics. There are like 72 hours, or you know. Well, can you go on mute? Actually, they're getting a bit of feedback.
Yeah. You should go on mute, please.
Yeah, so as I said, like in learning, there's a lot of playlists available in YouTube. Maybe have a watch, or you can read from book, up to you. However you want to, however you prefer. Cool. Any other question?
One more question is there. This is regarding how they can improve the accuracies in their this models, in learning models.
Yep.
Different, yeah, you described about the different techniques, different learning algorithms. So they're asking how they can improve the accuracies with respect to the different models.
Yeah, so accuracy you can improve at every step, as we touched upon earlier. So basically it starts at the very, very first stage, which is about data manipulation. What we have to do over there is we need to make sure, if any data is an outlier, or if any row is null, we have to impute. There is a process of imputation. So we need to make sure we are only feeding pure data to our model. If you need to impute those values, then you need to do feature engineering. Feature engineering is based on your problem. You need to choose the right feature. Some of the features, they may not impact your prediction. So what you do is you actually try to find those columns in the data set which are directly correlated with your problem. Some of the things may not be even relevant with that. We need to get rid of those models and those columns, and let our model focus on those features which are directly correlated. That's called feature engineering. Then you might also have to change your features a little bit, so that your algorithm is more suited to that. All those phases which we saw in the previous slide. Let me actually, I don't know whether I can share or not. But basically, in all those stages, we need to make sure they are chosen in such a way so that they're compatible with our algorithm. Other thing we can also do is there's a thing around stratified splits. So what stratified splits is, how we were talking about that 80-20% thing. So 80% is used for training, 20% is used for evaluation. You can have a revolving model on that. Like in the first round, you choose first 20%, and the next 80 becomes the training model. And then you can have a rolling window where, from 20 to 40 is used for evaluation, but the other is used for training. Then you can have like 40 to 60 use for evaluation, but the other is used for, that's called stratified splits. So there are a lot of ways. Other thing really important is to choose the right algorithm. You may be choosing a entirely wrong algorithm which is not suited to your problem. As I said, like there are around 80, 90 algorithms, and they're really complex ones. So you need to actually understand how these algorithms work behind the scene, how which data structures they use. Then you can actually apply them in the right way. It comes with experience.
Yeah, okay, thank you.
Sir, one more question, sir.
Sure.
Sir, AI and ML is not new concept, no, sir. It's very old. From 1960s, we can find these technologies. But why we are finding only in this 2020, this machine learning is very trending. That the same data we are having from 1960s, no, sir. We are having lots and lots of data. But why it is most popular only in this 2020?
Yep. So the main reason for that is, firstly, you're right. The data is there. The algorithms are really old. It's nothing new. But the main thing is the computation power. Earlier those computers, even if you recall, during 2000, those computers were not as fast. So now what these algorithms can do is, because we got a lot of CPU capacity, or lot of powerful CPUs are there, because they also use something called GPU, which is graphical processing unit, which is highly efficient at doing mathematical transactions. So because now modern computers are coming with GPUs, so that means these GPUs, or CPUs, or the processors, they can quickly run through all the combinations, and they can build highly efficient models. Because of this new advancement in the hardware, so that's why machine learning is getting more and more important. And other thing is, back in the days, the data sets were collected manually, or we might have databases as well, but these days data is coming on the fly. If you would have heard about the big data concept, where all these devices like your watches are generating data, your mobile phone is generating data, and in the cars there are sensors. So there are a lot of electronics everywhere which is generating a lot of data through using Wi-Fi, so we can process them on the fly. Because in machine learning, the main thing is, it has to act on the current data. It has to act on the data which is only 2 seconds old or only 5 minutes old. So there's no point of looking at the data which is 5 years old or even 5 weeks old. That's a stale data. So the more accurate algorithms, they need to adapt to the data more quickly. So that's why with all these advancements in technologies, where data can be quickly fed to the machines, quickly computed, and models can be rebuilt to align to that data, which is only possible now with all these advancements. So that's why it is getting more and more popular.
Sir, one more doubt, sir.
Sure.
Sir, machine learning will be able to predict correctly and it will give very good accuracy, right? Then what for this deep learning element existence? And if deep learning is good, then can I integrate this deep learning technology with cyber security? Like, can I hack that neural network and I can manipulate data, and I can do something like that? Can I integrate this with some other technologies like hacking and all?
Yes, deep learning is also doing a lot of advancements, you're right. But deep learning is more used around visual recognition. And yeah, so I mean, the thing is, there are people who are also trying to not use the technology in a positive sense. So you're right, as you can see, there are a lot of deep fakes and all these things happening, where they change the person's face with a different voice or something. So that is that is a manipulation of technology in the wrong manner. I mean, the whole thing is, yeah, so deep learning is also getting a lot of media presence and all those things these days. But yeah, I mean, you can play around with it, but that's more suited for visual pattern matching and those kind of things. But yeah, I won't recommend hacking or any that kind of thing, because it can land you into trouble. Yeah, I hope that may make sense.
So, guys, thank you so much, Mr. Manny Grewal. Thanks for providing the insights for all the processes that are involved in this machine learning developing models, and then coming on to the conclusions right from this. data cleaning and then training data and then learning algorithms and training models and then evaluating and then coming on the conclusions. It was a very amazing session providing insights in all those details and with the practical hands-on. And Mr. Manny has opened the platform. So in future also we can have our queries discussed with him. For the time being, you can send the queries at this email ID. My email ID is there. amandeep.singh@gga.ac.in, and in the future we can have some common platform where the queries can be addressed by Mr. Garipal itself. So, guys, thank you so much for sparing your time, and thank you, Mr. Manning Garewal, for sparing your so much of a valuable time for the students of Puzar to the Top Institute. It was really an eye-opener session for us. Thank you so much.
Thanks, guys, for having me. I hope it was useful and hope you understood something out of it. So, thank you very much for your time.
Yeah. We'll be looking forward for implementing all the details that you have provided to us and to our students. Thank you.
Thanks, guys. All
And
the best.
students, just a second. Students, you need to fill the form, attendance forms. You will be having those forms, form link in your email IDs, the email ID with which you have registered in this session. So you'll be getting the form link and you will be required to fill that form by today itself. So for the time being, we can disengage students. They can leave. Yeah. Thank you so much. Yes.
Yes.
Thank you. Thank you, Mr. Manny. Thank you so much. Thank you. So you can send your queries. I will try to collaborate on with Mr. Correa so that he can provide some common platform where you can post your queries and he will be able to reply back. Maybe due to the work constraints, he may not be able to reply as soon as possible, but he will be replying to almost all the queries. So we'll be coming back with some common platform where you can post your queries. For the time being, you can post the queries to my email ID, and I can collaborate on those queries with Mr. Garewal itself. Thank you, guys. Thank you so much for sparing your times. This is and Ankit sir. Is it? Are you there, sir? Ankit sir. So attendances will also be there. We have captured the attendance and the attendances will be there. So after filling that feedback form, you all will be getting your certificates also. So from Mohit, you will be getting the email regarding this attendance. Please stay alert and keep checking your emails. You will be getting in the next 15 to 20 minutes. Yes, you'll be getting the attendance form link in the next 15 to 20 minutes. From here, from this Google Meet, you can all leave.
Hi, sir.
Yes?
Thank you for the session.
Yeah, thank you. Thank you so much. Whatever emails you have used for registering this, for participating in this event, on those emails, you will be getting this form link. The emails which you have used for registering in this live webinar, on those emails, you will be getting